Hi, welcome back to the breadboard and another Roadtest sponsored by Element14. Today we have a new Keysight oscilloscope to have a look at. So in this case it is the X1000. I think there's been a few reviews already gone out. This is the first one from Element14 out to the Roadtester crews. Let's go have a look. I'm not going to waste too much time doing an actual unboxing because basically it's a box with a bit of polystyrene and the oscilloscope stuck inside it. There's nothing else too much fascinating except that it's well packed. So let's get it out and have a look. So here it is, partially unboxed. As you can see, very well wrapped, simple plastic bag and lots of high density foam to prevent it getting damaged in transit. So let's just remove that. So physically this unit is not huge, but it actually has quite a bit of weight to it. So there's our basic oscilloscope, and just looking right off the bat, the one I have here is a 100 megahertz version with the waveform generator output. It's dual channel with an external trigger, and I happen to know already that the external trigger can also be used as a logical input. So really it's kind of like a 2.5 channel, 3 channel oscilloscope, not a 2 channel. On the back of the unit we've got the standard power connector and a USB port. There is a cutout for a LAN, but I'm not aware of any option that actually allows that to be fitted. Perhaps I'll have a look inside and see if I can see if there's an option to put a connector on there, or maybe just check out Dave Jones's blog where he's already ripped one of these apart. So anyway, that's the basic unit. So we'll power that up in a moment and see what we get. I'm not sure what software options are in here, but it does have the option for software, serial decoding, both I2C and serial bus as well, and I think a bit of SPI too, but we'll check that in the specifications. One of the packagings that came with it is the scope probes, so let's have a quick look here. 2 probes. So if you want to use the digital input as a channel, you'll have to get an extra probe. So these are passive probes, and they are, let's have a look at the frequency range. They're actually 200 megahertz passive oscilloscope probes, so they're actually set for twice the frequency of the oscilloscope, probably because of software upgrades and various other things. They're just sending out the higher end scope probes so that you don't have to reorder them or anything like that if you do any software upgrades, although I'm not sure what the limit is yet on what the oscilloscope will go to beyond 100 megahertz. Standard adjustable clips, color coding for the cables, standard customized mains cable, in this case for North America, so it's the 2 flat and 1 little round prong. Calibration certificate, that's really just the certificate, it doesn't actually give you the details of calibration, and it's just a parts list, and that's pretty much it. So let's get a closer look at the oscilloscope and we'll power it up and see what options are available. This is basically just the unboxing first view look of the oscilloscope, so we'll run it through its paces in another video. So let's zoom in and have a look. Okay, so here's the oscilloscope. I've plugged in the probes. Nothing's been turned on yet, so this is going to be an absolute first time turn on. I've plugged the 2 probes into the channel 1 and 2, but I haven't trimmed them or anything like that either. So let's see what happens. So the only thing I've done is remove the plastic cover off of the display. Let's power it up. Didn't see any lights to start with when I powered the rear power in, so I'm only assuming that it's actually a hard switch, which it feels like too. Nice bright colorful lights by the look of it while it's doing its power up sequence. Okay, and there's our initial display. I'm just turning on channel 2. Let's see if it will 0. Yeah, it's right on top, I think. Oh, using the wrong thing. There's the green channel. So that's both of them set the same. Now let's see if we got some basic information here. It's not a touch screen. but we've got probe setups. So the probes are set for ×1 right now. I normally use them in ×10 mode, so I'm going to set this for ×10. Just trying to find what to use to adjust them. Probe ×1. Does it detect? No, it does not detect. It says the green. Yeah, it does say this button here. So probe. There we go. Don't need to push the button. Just set it for ×10. And we'll do channel 2. Probe ×10. Channel 1. Probe. Probe ratio ×10:1. Okay, that's both probes set. Okay, so to find out what we want to look at, we press Utility, Service, and About Oscilloscope, I think. There we go. So what we can see here is that we have model number DSOX1102G, with G meaning it's got the waveform generator, serial number bandwidth 100 megahertz, firmware, installed licenses, EMBED, Auto, SGM, mask, bandwidth 10, BW10, I assume that's the 100 megahertz version, wave generator, RML, and EDK. I'm not sure what all of those are actually for, like the EDK and the RML, but embedded is, I think, the serial decoding. Anyway, we'll look it all up and have a look online to see what they are. The latest version of the oscilloscope software can be downloaded from here, datasheet, etc., etc. So it looks like we have pretty much all of the software options loaded up, and the 100 megahertz scope is officially confirmed there. So that's really cool. Let's have a little look through and try a few things out. So the first and obvious thing is to hook onto the probe compensation outputs. I guess I already happen to have it on the correct frequency to trigger those. So there we go. Haven't adjusted anything yet. And as you can see, we've got actually quite a good setup already. I don't think tweaking these is going to improve them. We can have a look and see. But I don't think, yeah, it's already set nicely for the number channel 1, and probably the same for channel 2. I don't see why didn't have channel 2 set to ×10 compensation. And there we go. So that's those two set nicely. I think they were already set okay. I just messed it up because I had it on ×1 when I was trying to tweak it before and messed out the settings. So now it's back to where it should be. Okay, so a few observations as we look around this. Display is nice and bright, nice decent size to it. The buttons, there's no touch screen, but at this price range I wouldn't expect there to be. USB at the front for connecting a USB stick. I'm assuming you could probably also connect a keyboard to that or something. We'll test that out later. All of the knobs seem to be detented, so there's a nice positive click for them. Yeah, all of those. Obviously the up and down movement ones are not. Wave generator buttons are separate here for FFT, maths, reference, and wave gen. We have the external inputs. We've got a button dedicated to save to USB. Display allows us to set persistence, grid. Yep, that's pretty good. The grid was not fully, but you can actually take that off if you want. That's nice. Let's just go back. What have we got? Labels, annotations. So that's where having a keyboard connected would be handy. Clear display. Probably just clears anything you might have added. Let's just go back. Standard analyze. So features frequency response analysis, mask testing, analyze video, input source channel 1 or channel 2, auto setup and grid full. Yeah, so we'll have to have a look, see what we can do with that after. All the buttons, the actual feel is quite nice. There's a few that are actually recessed here for things like auto scale and default setup, probably so that you don't accidentally press them after you've carefully adjusted all of your ranges. Reference is that. Okay, we'll have to go through that. Wave generator, waveform, square wave, frequency, amplitude, offsets, duty cycles. Waveforms, you can select between looks like sine wave, square, ramp, pulse, DC, and noise. No arbitrary function in here, but that's okay. This still gives you a lot of choices for testing circuits out. What else? Acquire channel. So probably set your zoom, persistent, segmented. So we have segmented memory in the oscilloscope as well, which is really nice. Fast Fourier transform, source 1. And it looks like it's actually still leaving. Let's just turn off channel 2 for a second. So even though we're doing an FFT, a lot of oscilloscopes will turn off the normal trace. We have it still remaining here, which is pretty good. We can try this out later with the noise generator and also my 33622A true-form arbitrary waveform generator. We can feed a whole bunch of signals, but we'll also test the waveform generator that's built into this as well. We'll go through the specifications. I'll download the data sheet and we'll have a quick look in the second part of this video. Right now we're just doing a quick overview of a lot of the features that are in here. Intensity control, brings up a little gauge, that's quite nice. That's for the trace itself, the main signal traces. So it's set to 50% by default. Save and recall. Measurements, so we can add a measurement. Type source 1, type frequency, we'll add. So now we have it here, 1.0003 kilohertz. So that's pretty good. We'll have a look at some more things in a moment. Okay, so we've had a look at a bunch of the basic functions. Let's have a look at one of the serial protocol routines. What I've done here is I've hooked it up with a I2C lines on my ESP8266 talking to a BME environmental sensor that does pressure, humidity, and temperature. And so what we will do is see if we can actually decode. I've never actually looked at this before. Let's see how easy it is to get it decoding the I2C communications. So it's a bus protocol, so I'm presuming we're just going to press bus. We're going to select a serial bus up here. So we enable the serial bus. The mode, you can see here we've got CAN bus, I2C, LIN, SPI, and RS232. So the one we want, of course, is I2C. The signals, according to this, the yellow channel is SCL and the green channel is SDA. So I think I've got them hooked up the right way around, but I guess we'll soon find out. So we'll go back from there. What else have we got? 7-bit for addressing, that's correct. So we'll go back from there. I guess we need to turn on channel 2 as well. 5 volts, just make them 2 volts per division or something. Let's crank down the signaling rate. Triggering, I guess, we need to set up. So set for auto, let's go to normal triggering. Trigger type, source 1, slope. Now, when you're running a bus protocol, you often get a additional triggering, and here we have things like pulse width, a pattern, setup and hold, video signal, or a serial. So what we're going to pick is obviously the serial for the triggering, and there you go. Immediately it's now started triggering on a frame. Now this requests the parameters from the temperature, humidity, pressure sensor about every second. So if we just reduce the bandwidth here a little bit, yeah, so there's a sample, there's a sample, there's a sample. So that is 1, 2, 3 divisions at 1 second per division, right? Now obviously that is way too small to even contemplate reading. It can't decode at that, but let's just bump it back up now for just one of these. So we're not actually decoding it properly there at the moment. Let's just see if it's the triggering. Trigger on start, SPI. I think that's all we've got there too. Oh, levels perhaps might be the issue. But this is not using segmented memory either at the moment. So let's just change, probably in something like acquire. There we go, there's an acquire button. Segmented memory. So we'll turn it on. And we'll tell it we'll have 4 segments. Just arbitrarily picking things here. And let's run a trace again. So that's captured 4. Now we should be able to zoom in on that packet, which we have. So question now is, how do you step through the the extra segment? Yep, current segment. There we go. So that's segment 1, segment 4. It's exactly the same, I think. 3, 2. So we're looking at each segment now that we've captured. So one of the benefits, my other scope doesn't have segmented memory as such. So you can't do something like this where things are very fast when they happen, but spread apart quite a distance. So that's quite a nice feature to have in a effectively an entry-level but professional oscilloscope. What we can also have, so that's decoding some I2C, and we can see the data here. 76 right FA, 76 right F7, 76 right F1. Okay, I was misinterpreting the data slightly. Yeah, there we go. Let's just pick one of these, the first one for instance. So that's a complete packet now. So we're writing 76, register FA. We're reading back from 76 and we're getting 83, 56, 90. We're then writing for that. So it's going to read pressure. I might get these in the wrong order, but pressure, temperature, and humidity. So that will be the second one. So writing F7, reading back 5740 EO, and then writing 76 FD, reading back 66 B8. So, and then that's repeated every 3 seconds. So that's actually now nicely decoding the data. Anyway, this particular video is not a full review anyway. What it is a quick overview, sort of box opening, first impressions. What I'm seeing so far for an oscilloscope that's priced at around about $1,000 US, compared to my, for instance, Tektronix MDO3054, which is significantly more expensive. This thing with its protocol decoding built into it, being able to run at 100 megahertz and having all these other features built in too, like the waveform generator, etc., seems to be a great deal from what I can tell. The controls are very nice and responsive. I think the one annoying thing I've just found so far is the horizontal scale takes 2 idents every time you try to move it. The first one it just ignores for whatever reason. Have to look into that perhaps. I would have expected it to change on every one, like a lot of these other controls do. Yeah, they do on every single individual ident on the rotation, it will shift. But that one for the yeah, it's just every 2 clicks for some reason. So I'm not sure what's going on with that. Might be deliberate, might be a bug, who knows. The acquire menu, we've already looked at that. Auto scaling, reset to default setup. The entry button is basically a universal control for changing things. Analyze lets us look at threshold, source 1, features, so we can do things like mask testing, frequency response analysis. That's something we're going to look at in another video. Measurement thresholds and trigger levels. Measure is got the typical period, AC, DC, RMS, average, pre-shoot. It's got phase between A and B channels. So we'll have a look at all of these features. Quite a range of different measurement options, some of which I haven't seen on other similar kind of price scopes. So we'll have a look through those as well, play around with them. There's some quick action button which has not been assigned to anything yet, so that's probably user programmable to do some kind of function for you. We had the fast Fourier transform, which is effectively a poor man's spectrum analyzer. Not quite the same, but it's very, very similar. We have math capability, so what have we got here? Function FT and GT, operator, add, subtract, multiply, the source, channel 1 and channel 2, the source, channel 1, channel 2. So a bunch of math functions that can go between channel 1 and channel 2. So add, subtract, multiply. No functions, but you know, plenty of, no user definable math formulas. My Tektronix MD3054 will let you put in some formulas and things, but then you are paying significantly more money. But the basic features you've got here still allows you to do some differential measurements and things like that quite easily. You have the standard reference where you can actually store a waveform and recall it later for comparison. And the waveform generator, which we've already had a quick look at some of the values. It only goes up to 20 megahertz. Amplitude can go up to 24 volts peak to peak. So I'm not sure if that's with it terminated into 50 ohms. It probably isn't. It's probably 12 volts into 50 ohms. Let me just bring that back down again so it's at a reasonable level. 1 volt. Adjustable offset, settings, output load high impedance or into 50 ohms. Logic, so you can preset some logic levels if you're driving some particular devices. TTL, CMOS, 3.3 volt CMOS, 2.5 volt CMOS, and ECL. So that's quite a range of defaults for you. And some of these other options are not enabled at the moment. Oh, that's because we've got logic level versus one of the presets. No, that's not what it is. Default wave gen. Oh, there we go. Just hit default. Now we've got them. So you can add noise. You can invert the output. You can add modulation. And we'll have a whole bunch of play with a whole bunch of these settings when we do some frequency response analysis. This is a mode that this oscilloscope has that I haven't even seen on much more expensive ones, where you can actually use the waveform generator to drive, say, an op amp with a filter built in and measure its frequency response curve, basically a Bode plot, and also it measures the phase shift. So you output on your wave gen into an op amp or something, and you use channel 1 and 2 to measure the input signal and the output signal, and the oscilloscope will effectively plot on the screen for you a complete bode plot of the response of that circuit, which is really, really cool. The only thing I've seen, even on my MD03054, is to use the spectrum analyzer and independently use the arbitrary waveform generator to feed a signal in, but it doesn't actually link the two together the way that this oscilloscope will do that. So we'll have a play with that. I think it's quite a unique feature to this oscilloscope at the moment. Standard trigger leveling, safety, USB we've looked at, standard things like cursors. I think that covers pretty much all of the basic inputs and outputs. USB connection on the back to connect to a PC, so you can control it from LabVIEW, MATLAB, or Keysight's own analysis software. So we'll download that and hook that up as well to see how well we can talk to it. I might even try and dig out my old oscilloscope software that I wrote in C# under Visual Studio that could talk to my A10102 oscilloscope. That was another eBay cheapy 100 megahertz scope that I got quite a few years ago. Don't use it too much these days. Doesn't have protocol analysis or anything like that. But it was cheap, and it's all I could afford at the time, and it, it serves me well, and for basic measurements it works very well. I think that completes the first video for the quick unboxing of the Keysight DSOX1102G storage oscilloscope. I just want to thank Element14 for providing it to me, and Keysight, of course, for supporting the Roadtest by providing the instruments to us. And I'll be back very soon with another video where we start doing some experiments with it. Anyway, that's it for now. I'll come back on the next video. This one's getting a bit long. Hope you liked it. You know the drill, and see you soon.